Okay, question 9. So the way we are going to look at this question is it's effectively actually two questions. You've got parts A, B, and C, which are all relating to this first probability distribution. And then you've got parts D and E, which almost feel like a completely new question. So we will, first of all, let's just look at parts A, B, and C together, and we'll answer them, and then we'll go on to that next bit. All right. So a biased four-sided die with faces labeled 1, 2, 3, and 4 is rolled and the result recorded. Let X be the result obtained when the die is rolled. The probability distribution for X is given in the following table where P and Q are constants. Okay, so first things first, that we are gonna end up having to use this fact, but the probabilities of all these numbers here, including the constants, they're going to have to add up to 1. Okay, so that's always the case when you sort of roll a die or flip a coin. The probability of each event occurring, the sum of each of the probability of each event occurring, they need to add up to 1. So, for example, flipping a coin, 50-50 heads and tails, given it is an unbiased coin. So moving on, we have for this probability distribution, it's just known that the expectation of X, so EX is equal to 2. Part A asks, show that P is equal to 0.4 and Q is equal to 0.2. And then find, let's just look at part A for now. And what we will do is we'll take all this, we'll bring this down to a new page. Bit more room. Okay, cool. Lovely. So given that we know that each event, the sum of the probabilities of each event, we know that these are going to have to add up to 1. So that can be our first equation, right? So we're going to write that in. So we're going to say P plus 0.3 plus Q plus 0.1. This is going to have to equal 1. All right. And then now if we wanted to sort of simplify this or clean it up a bit, we could sort of bring the 0.3 and the 0.1 to the other side. All right, so we can subtract that. So the sum of them would be 0.4. So if we did that, come down to a new line and say subtract 0.4 from each side, that would give us P plus Q is equal to 1 subtract 0.4, which is 0.6. All right, cool. So there is a start. Okay, so there is an equation in terms of P and Q. And funny enough, we can see that if P was 0.4 and Q was 0.2, that would satisfy this equation. But now to completely show that, to confirm this, we're going to have to use this information here that the expectation of X, so the expected value of X, is 2. Now the formula for the expected value of a probability or of a probability distribution is given to you in your formula booklet. Let's just go have a look. And so that is going the wrong way, sorry. Down here we have expected value of a discrete random variable. All right, so here, in fact, we'll include the little SL bit so you can see whereabouts in your formula booklet it is. Okay, and so this bit states here, let's lob that up there, that EX is equal to X, little x, which is this line up here, that line up there, multiplied by the probability of that given X value occurring. Okay, and it's the sum of that. That's what this sigma sign equals. Okay, so that means EX, which we are told is equal to 2, will have to equal 1. So that's taking up the 1 bit there, multiplied by P, okay, because that's the probability of X being equal to 1. All right, then moving on, so then we're going to have to add up the next one. So this is going to be 2 multiplied by 0.3. All right, then plus 3 multiplied by Q plus 4 multiplied by 0.1. Okay, and so then that's going to have to equal 2. So now if we go through again and we sort of clean this up a bit, we're going to get 2 is equal to, well, 1 times p is just going to be p. 2 times 0.3 is going to be 0.6. Okay, 3 times q is going to be 3q. Okay, and 4 times 0.1 is going to be 0.4. So we'll put that over here. And then now to clean it up again and sort of have an expression in terms of p and q just by itself, what we will do is we'll subtract the sum of 0.6 and 0.4, which come to 1. So we'll just subtract 1 from both sides. That will leave us, I'm going to swap the sides here so we can sort of get our p and q on the left-hand side, sort of in a similar fashion as we have up here. So we're going to get p plus 3q is equal to 2 subtract 1, which is just 1, right? And so now effectively you have two equations. We can call this equation 1 and this equation 2. All right, and now we're going to have to run simultaneous equations or sort of solve these equations simultaneously. There are a few ways you can go about this. There is the elimination method, which I'm going to use here. There's also the substitution method where we could sort of get an expression. Yeah, definitely I'd say recommend probably using this one here. We could say that q is equal to, or even p is equal to 0.6 minus q. And then we can substitute that in for our second equation. That's a valid method, but I'm going to show you the elimination method in this case, because we have we've got sort of just 1p here and 1p here. All right, so what we're going to do is effectively the equation 2 subtract equation 1, and that's going to look a little bit like this. Okay, so we're going to sort of write equation 2 on top, and so we'll write p plus 3q is equal to 1, and now this is going to be subtract p plus q is equal to 0.6. Now I draw a line under this, and now we sort of subtract all the terms, and you'll sort of get from the name that I said the elimination method. And so essentially what happens here, because the coefficient of our p's are the same and we're subtracting the two equations, the p's are eliminated from the equation. So we get p minus p, which is nothing, and we get 3q subtract q, which is going to give us 2q, and then this is equal to 1 subtract 0.6, which is equal to 0.4. Okay, and then we can sort of then say, therefore, if we divide both sides by 2, we'll say divide by 2, and we can say that means q is equal to 0.2. And then now what we're going to do to find the value of p, or show that the value of p is, as we're sort of told here, 0.4, I'm going to substitute in, okay, sub q is equal to 0.2 into either equation, but in an exam, I would say venture to suggest or encourage you to use the easiest and most efficient equation possible. And in this circumstance, it would be equation 1. There's less calculation. There's calculations to do. All right, so we're going to sub that into equation 1, and so that's going to be p plus 0.2 is equal to 0.6, and then we'll do a little sign. We'll subtract 0.2 from both sides, which will get our p by itself, and we get p is equal to 0.4. And then that is the answer to part A. Okay, on to part B. So part B asks, find the probability that x is more than 2. So we'll go through and do similar process as before. Bring this down to a new, we'll go onto a new page. All right. And so we already know that P is equal to 0.4 and Q is equal to 0.2. And if we're finding the probability that X is greater than 2, and we have here a discrete random variable, that means the two possibilities that we need to consider is the probability that X is equal to 3, all right, plus the probability that X is equal to 4. All right, cool. And we can quite easily get that from the Q, which was 0.2. We can even put 0.2 here. We can put 0.4 over the top there. And so this is going to be 0.2 plus the probability that X is equal to 4, which is 0.1. And so the answer is 0.3. And I'm going to copy this down for each line. And there we go. That is the answer to part B. Okay, on to part C. Let's go up. So Nikki plays a game with this 4-sided die. In this game, she's allowed a maximum of 5 rolls. Right, let's highlight that up. Maximum of 5 rolls. And we'll extend it to include the idea of it being the maximum. Okay, her score is calculated by adding the results of each roll. Nikki wins the game if her score is at least 10. Okay. After 3 rolls of the die, Nikki has a score of 4. Okay. Part C says, assuming that rolls of the die are independent, right? So that's going to be important, the fact that they are independent. Find the probability that Nikki wins the game. All right, and then after 3 rolls, her score is only 4. She has a score of 4, which is somewhat unfortunate when we think about, how she's managed to get a score of 4 and from 3 rolls. And if we look back at our, our table up here, okay, you see the only way she will have managed that is by getting 2 1s and then a 2. So she started off pretty unlucky in this game, to say the least. All right, let's copy down information to a new page, and we will we'll go from there. All right. Yeah, we can go. We'll put it in here. All right. So if she's already done 3 rolls, okay, that means she must have 2 left. Yeah. So we'll put in C here. We'll say Nikki has 2 rolls left, and in order to win, she must score 10. She must score 10 from the 5 rolls. So, and if she's already got a score of 4, that means she must score at least 6 in these 2 rolls. Okay, so she has 2 rolls left and must score at least 6 to win. All right. Okay, so now we've got to consider the possibilities of Nikki scoring 6. Okay, so if we look back at our table, in fact, what we could do, we'll just copy this bit here and bring that off to the right. Let's do that. Paste image. Yeah, that'll do. That's not too bad. Okay, cool. So the ways that she can score a 6. Okay, so the probability, so we'll say P win. So the probability that Nikki wins will be the probability that she rolls a, well, we can't make any sum of 2 rolls with using 1. So if she gets one more 1, right, considering she's already got 2, because if she's on 3 rolls and gotten a score of 4, that means she will have had to roll 2 1s and 1 2, which is unfortunate. Yeah, so she can't roll a 1 at all. She could roll a 2 on the first roll, all right, and then a 4 on the second roll. She could do that in reverse order as well. So she could do a probability of a 4 and then a 2. All right, then the probability of getting a 3 and a 3. All right, there we go. And then equally, we could say if she got the probability of getting a 4 and a 3 and a 3 and a 4, because that would add up to 7, which is at least 6. So that's also going to count. So we'll say plus probability of a 4 and a 3 plus the probability of a 3 and a 4. And then equally, if she rolled 2 4s, that would sum up to 8. And so that would also be okay. That would make Nikki win. So probability of a 4 and a 4. Okay. And so now if we go to our formula booklet and we try to find the probability of 2 independent events occurring, we will see that in our formula booklet here. Let's go find it. It's in the 4 section, topic 4. And so here, all right, so this idea here, independent events, okay? The probability of A and B occurring, okay, is the probability of A times the probability of B. All right, so that's what we're going to need here. Let's just take that, copy that over. What am I doing? So all of that there. All right, so then now in order to calculate the probability that Nikki wins, we need to add up all these probabilities. And in order to do that, we're going to need to multiply. So for the first one, we're going to have to multiply the probability of getting a 2 and then a 4. Okay, so we're going to have to find the product of that. So that's going to be 0.3 times by 0.1. Okay, and then we get the same thing, but in reverse order, which is going to equal the exact same thing. So I'm going to write it all out. But what would be also, equally fine and probably more efficient in an exam is you could just multiply this bit here by 2, just one of them by 2. And if you put a coefficient of 2 and you're working, the marker will know what you're doing and they'll see that you understand that they're going to be the same thing. But I'm going to write out each thing as their own occurrence, if that makes sense. All right, so then the next one is going to be probability of a 3 and then a 3, which is going to be 0.2 times by 0.2. Equally, you could just put that as 0.2 squared. Probability of a 4 and a 3 is 0.1. 0.1 times by 0.2 plus the probability of then a 3 and a 4, which is 0.2 and 0.1. Sorry, yeah, the exact opposite of that. So that switched around. And 2 4s is 0.1 times 0.1 or 0.1 squared. Okay, and so now we're going to have to go through, calculate all of this. So 0.3 times 0.1 is going to be 0.03. Okay, 0.1 times 0.4 will be 0.04. Sorry, 0.2 squared or 0.2 times 0.2 will be 0.04 as well. 0.1 times 0.2 will be 0.02. And yeah, that's repeated for the next one as well. 0.2 times 0.1, so 0.02. And then 0.1 times 0.1 is 0.01. Okay, cool. Now we're just going to add all these up. So we got 0.03 plus 0.04 plus 0.04 plus 0.02 plus 0.02 plus 0.01. And that will give me the 0.15. Okay, take your time with these ones. It's quite easy to get them off by one digit. But yeah, I recommend just going through. So 0.03, 0.04, so you get to 0.07, then 0.11, then 0.13, 0.14, then 0.15 at the end. You kind of saw how I went through there like that as we work from left to right. Okay, and then that is the answer to part C. So that's the probability that Nikki would win the game. Okay, now let's move on to part D. Okay, so part D and E, brought them down to a new page. So David has two pairs of unbiased four-sided dice, a yellow pair and a red pair. Both yellow dice have faces labeled 1, 2, 3, and 4. Let S represent the sum obtained by rolling the two yellow dice. Probability distribution for S is shown below. Okay, cool. So that's given here. First red die has faces labeled 1, 2, 2, and 3. And the second red die has faces labeled 1, A, and B, where A is less than B, and A and B are both an element of positive integers. Okay, the probability distribution for the sum obtained by rolling the red pair is the same as the distribution for the sum obtained by rolling the yellow pair. Okay, cool. And part T asks, determine the value of B. So when we think about our two dice, our two red dice, we'll say on our first one, okay, we have 1, 2, 2, and 3. And then let's put our second one here, where we've got 1, A, and B. Okay. And we know that A is less than B. Okay. And when we look at the probability distribution that we've got up here, okay, if we look towards the 8 column, all right, there has to be only one possibility from rolling our two red dice, that sum to 8. Okay. And then when we look at our the possibilities that we have, we can get sort of 1 and 1, all right, and that would represent 2, and that will give us our 1/16. So that's already taken care of. We're going to get 1 and A, 1 and A again, and 1 and B. All right, so we're not going to be too concerned about the 1 idea, because there's no way we're going to be able to get 8 or just one value of 8, and that being our highest value. So we've got to skip all the way to the 3 on the first dice. Okay, so we're going to assume that we have rolled a 3, and then there has to be one possibility from rolling the second dice where the sum of our two dice will add up to 8. I hope that made sense. Okay, so if we went for 3 and a 1, we would get 4, and so that's not going to be good. We could get 3A and then 3A again, and if that was to sum to 8, so let's say if A was 5, okay, that means we'd have to have two possibilities of summing to 8, and then we'd also have to have a possibility that is a sum that is higher than 8, because we are told that A is greater than B. So other way around, so A is less than B. So with that being said, why is that constantly giving me a little dot? So yeah, there we go. All right, so with that being said, that means 3 and B will have to sum to 8, and there's only one possibility of that happening, which is 3 and B. So then therefore we can conclude that B is equal to 5. So yeah, a bit of thinking involved with that one. But yeah, so that is the answer to part D. Okay, and part E asks, find the value of A, providing evidence for your answer. All right, so the best way to go about this will be to create a table of sums or of results, from rolling the two dice. All right, so the way I'm going to go about that is I'll put the first dice up the top, so we can have sort of, we'll go 1. In fact, what I can do is I can even just copy this, right? I can just bring this down. 1, 2, 2, and 3, and then on the the vertical, in the columns, I suppose, we'll put the second dice. So we'll go 1, A, and B, and now let's. In fact, we know what B is. B is 5, so let's lob that in. 5. All right, and so now if we create this table, we'll go like this. There. Okay, cool. And now let's add in our vertical lines. All right. And let's just copy that. I'll just bring that over there. All right, sweet. That will do. And we'll bring these down. Okay, so now when we look at our first column, we've got a whole bunch of different possibilities, and let's put in right in the sum of each possibility. I'm going to put this in a new color. All right, so we're going to say, yeah, this is 2 because we get 1 and 1. When we get 1 and 2, which will be 3, 1 and 2 will sum to 3, 1 and 3 will sum to 4. Okay, cool. Now on to the next line. So here we have a and 1, so we can call this a plus 1. Then this can be a plus 2, a plus 2, and then a plus 3. Equally, then this line is going to be exactly the same. A plus 2, and then a plus 3. And then lastly, we can put in 6, 7, 7, and 8. And so we have 16 possibilities in our table, which is correct from our probability distribution table, which I'm also going to bring. Let's bring that down as well. Okay, so let's stop that there. Now let's start to equate. So have we got one possibility, 1 out of 16, that is equal to 2, and that's correct. We've got that. We've got 2 possibilities that are equal to 3, which are here. Okay, 4 possibilities. Sorry. So the sum of 4, we're meant to have 3 possibilities. Okay, and we have 1 of them in our table, so that's going to be helpful. Or what have I done? We've got 1 of them in our table. Okay, and then so on and so forth. But the easiest way to answer this is that in our definite sum, so in this top line here, okay, and then this bottom line here, we have no options or no sums of 5. Okay, so that means therefore some of these sums here are going to have to add up to 5, right? And there's going to have to be 4 possibilities for them, all right? So if we get rid of these highlight here and we see which occurrence with A in it has 4 possibilities, well, that's going to be these middle 4 possibilities, okay? So these guys are going to be our 4 possibilities that add up to 5, all right? So I'm trying to, let's actually highlight all the individual terms as well, all right? So these terms here have to add up to 5, so if the probability that s is equal to 5 is equal to 4 over 16, therefore a plus 2 will have to equal 5, because that's the only one we have with 4 possibilities. And so then we can say, therefore, a is equal to 3. And that is the answer to part E.